Well, hey everyone, and welcome back to another episode of F.O.A Maths. Today we are going to be practicing what we learned in the last video, which was divisibility shortcuts for the numbers 2, 3, 5, and 9, and 10. I think that was all of them. But in any case, we're going to get comfortable with those ideas, and so I have 6 questions prepared for you here. So if you want to pause the video and look through them yourself, please do so, and we'll get right into them. Also, this is extremely hype. I have new pens now, so that's pretty cool. Let's crack open this fresh new black pen and go on to number 1. So this says number 1 is divisible by number 2. True or false? Justify your answers. So we have this statement that number 1 is divisible by number 2. Now this isn't saying 1 is divisible by 2 because that's not true, right? 1 divided by 2 isn't a whole number. But this is saying that we have 2 numbers and we don't know what they are. But the first one is divisible by the second one. And so now we have 3 statements here, and we need to determine if they're true or false. All right, so the first one says number 2 is a factor of number 1. So number 1 is divisible by number 2. I can write that out. So that basically says number 1 divided by number 2. That gives us some whole number, right? So if we know that number 1 divided by 2 gives us a whole number, then can we use that to determine if number 2 is a factor of number 1 or not? Well, it's going to be, and we saw in the last video that being divisible as something had a relationship to being a factor, namely that if we saw something like 10 is divisible by 5, right, since 10 divided by 5 is 2, then it follows that 2 times 5 equals 10, which makes 5 a factor. So similarly, number 1 divided by number 2 giving us a whole number means that we're going to have that number 2 times that whole number will have to give us number 1, right? Which means that number 2 is going to be a factor of number 1. So part A is true. Number 2 is indeed a factor of number 1. Now let's get part B. Number 1 is a multiple of number 2. Well, similarly, we saw that number 2 times a whole number gave us number 1, right? That means that we're taking a whole number amount of number 2 to get number 1. Or namely that number 1 is indeed a multiple of number 2. So this is a true statement. Right? Similarly over here, if we look at kind of the example where we're using pure numbers, we have 2 times 5 is 10, right? We knew that from the statement 10 was divisible by 5. And that means that we're taking multiple 5s to get 10, which means that 10 is indeed a multiple of 5. All right, let's move on to part C. Number 2 can't be divisible by number 1. All right, so number 2 divisible by number 1 would mean something like number 2 divided by number 1 gives us a whole number. Okay, so this is kind of the claim we want to see if that's true or not. We already know that number 1 divided by 2 gives us a whole number, but is it going to work the other way around? Well, not necessarily, right? We see that if we have 10 divided by 5, that equals 2. That's a case where, yeah, 10 is divisible by 5. But 5 divided by 10, that's 0.5. That gives us a decimal, right? Not a whole number. So in this case, it's not divisible by 1. So we might be leaning towards saying that, yeah, number 2 isn't divisible by 1. So this should be a true statement because it says number 2 can't be divisible by number 1. But the thing is, it's saying it can't be divisible by number 1. Like there's no situation where it would be divisible by number 1. But I can give you a situation where it will be. So let's say number 1 is 10, and let's say number 2 is 10. Well, we know that 10 divided by 10 is 1, and that means 10 is divisible by 10, right? So number 1 is 10, it's divisible by number 2, which is 10. But if we flip those, well, number 2 is 10, and number 1 is 10. So when we divide those, we still get 1, right? So it is a very special case where number 1 equals number 2, where like they're both the same number. But that is a situation where number 2 can be divisible by number 1. So that means part C has to be false, because part C, it's making a claim for number 2 and number 1 in general. It doesn't refer to any specific number. We can't rule out the possibility that number 1 and number 2 are actually equal. All right, so let's go on to part 2. Are the following numbers divisible by 2? All right, so we have several numbers here, and we want to see if they're divisible by 2. So let's recall what the test was to be divisible by 2. Well, it was odd numbers are not divisible by 2, and even numbers are divisible by 2. All right, so we just have to check if these are odd or even. So 40, that ends in a 0, so that number is even. So therefore, it is divisible by 2. And I'm just using div dot to be a shorthand for divisible. All right, the next number is 1092. Is that even or odd? Well, it ends in a 2, so it has to be even. So we can say the exact same thing. Therefore, it is divisible by 2. And if you haven't seen this before, these quotations just mean it's like the same as the line above it. These are called like dittos, I think. So, ditto. All right, next number, 2,341,011. Is that odd or even? Well, it ends in a 1, which is not an even number, so this number has to be odd. So therefore, it isn't divisible by 2. All right, and then next up we have 311. Is 311 odd or even? Well, same as the one above. It ends in an odd number, so it is a odd number itself. So we can say the same thing. Therefore, 311 isn't divisible by 2. All right, so it's pretty quick, and I mean, that was the point of these rules. It's a very efficient way of checking if they're divisible by 2 or not. And for extra practice, just the way I made this problem is I picked some random numbers and asked you if they were divisible by 2. So that's all you have to do. Just maybe find a random number generator online, or be a little crazy and make your own numbers, and then just check to see if they're divisible by 2. You can do this all day if you want, and you can get extremely comfortable with this concept. All right, let's move on to part 3. Are the following numbers divisible by 3? How about 9? All right, so this is like a 2-in-1 kind of thing where we're going to be doing 2 tests on all of these numbers. So let's start with what are the divisibility rules for 3. So for 3, if the sum of digits is a multiple of 3, then the number is divisible by 3. And for the rule for 9 is if the sum of digits is a multiple of 9, then the number is divisible by 9. And if you want some more details on these rules, you can always go back to the corresponding lecture video. All right, so these are our 2 rules for divisibility by 3 and divisibility by 9. So now let's look at each of the numbers. So 17. So both of these rules involve adding the digits. So we're going to add the digits for 17. So that's 1 plus 7, and that's 8. So now we check, is 8 a multiple of 3? Well, it's not, right? If we count by 3s, we're going to pass 8. So not a multiple of 3. So not divisible by 3. Right, so 8 is not a multiple of 3, so 17 is not divisible by 3. All right, and 8 is also not a multiple of 9, right? 9 is bigger than 8, so it's definitely not a multiple of 9. So 17 is not divisible by 9. All right, so 17 is divisible by neither 3 nor 9. All right, let's look at the next number, 2,181. All right, let's add up those digits. So we have 2 plus 1 plus 8 plus 1. Let's see what we get. 2 plus 1 is 3, plus 8 is 11, plus 1 is 12. All right, well, 12 is a multiple of 3, right? If we do take 4 3s, we get 12. So that means 2,181 is divisible by 3. All right, so the rule worked out for us in this case. 2,181 is definitely divisible by 3. What about by 9? Well, 12, is that a multiple of 9? It is not, right? So that means 2,181 is not divisible by 9. All right, so far no luck with the divisibility by 9, but maybe this next number will do it for us. It's a pretty big one too. We have 111,777,111. So this is kind of a nice symmetrical number here. And if we add up the digits, we have 1 plus 1 plus 1 plus 7 plus 7 plus 7 plus 1 plus 1 plus 1. All right, so we have 3 ones here. That's 3. And we have 3 sevens here. That's 21. And we have 3 ones here. That's 3. 3 plus 21 is 4 plus 3. That is 27. 27 is a multiple of 3. Right? 3 times 9 is 27. So that means this number here, 111,777,111, is divisible by 3. And 27, is that a multiple of 9? Yeah, 9 times 3 is 27, right? So this is a multiple of 9. So 111,777,111 is also divisible by 9. So we have a number here that's divisible by both 3 and 9. So that's pretty nice. And let's look at the last number. All right, so the last one was 311. So let's add up its digits. 3 plus 1 plus 1. 3 plus 1 is 4 plus 1 is 5. 5 is not a multiple of 3. So 311 isn't divisible by 3. And 5 is not a multiple of 9, right? 9 is bigger than 5, so we're not going to ever get that 9 times some whole number is 5. So it is not a multiple of 9. So that means 311 is also not divisible by 3. All right, great. So that was number 3. And just like with number 2 for extra practice, pick any random number you want and use these rules to test if it's divisible by 3 or 9. All right, moving on to question 4. Are the following numbers divisible by 5 or 10? So questions 2, 3, 4, they're pretty formulaic, right? You kind of get the idea at this point. But let's get familiar with the 5 and 10 rules in any case. So what are the rules for divisibility by 5 and 10? So if the number ends in a 0 or 5, it's divisible by 5. And if the number ends in a 0, it's divisible by 10. All right. So let's look at the first number, 124. Well, does that end in a 0 or 5? No, it ends in a 4, right? So it is not divisible by 5. And it also doesn't end in a 0, right? So it's not divisible by 10 or 10. All right, so that was 124. Nice and easy. 2,310. All right, well, this one is divisible by 5 and divisible by 10 because it ends in a 0, right? So it is divisible by both 5 and 10. All right, man, these ones are pretty easy, way easier than the 3 and 9s. This one ends in a 5. So that means it's divisible by 5, but not by 10, right? Because 10 is only zeros that it'll work for. So divisible by 5, not 10. All right, and then this last one here, we have 0. All right, 0 is a bit of an interesting one. Well, 0 is actually divisible by any number. Because if you think about it, what's 0 divided by some number? Well, you're taking 0 things, you're dividing it amongst however many people. They each get 0 things still, right? So 0 divided by 3 is 0, 0 divided by a million is 0. It doesn't matter what we divide 0 by, we're always going to get 0, which means that, yeah, 0 is just divisible by everything. So automatically it's going to be divisible by 5 and 10. But we can also use another line of reasoning here. A number is divisible by 5 if it ends in 0, and it's divisible by 10 if it ends in 0. But hey, 0 kind of ends in 0 in a sense, right? It doesn't have any other digits, but it is 0, right? So this is divisible by 5 and by 10. All right, so, and similarly, just like with 2 and 3, pick any random numbers you want and see if they're divisible by 5 or 10, and you can just do a ton of those till you get comfortable with these rules, but I'm guessing for 5 and 10, you're going to get comfortable with those pretty fast because it's just checking the final digit, just like with number 2. All right, great. We're making some groovy time today, so let's go on to number 5. 5 and 6 are a little more interesting, I think. So this says, prove the following claim. And in math, whenever I say prove the following claim, the idea of proving something means basically I have a statement here, but you need to like show me that the statement is true. You need to, well, prove it for me, right? So this statement says if a number is divisible by 10, then it's divisible by 5. So let's write that out. If a number is divisible by 10, then it's divisible by 5. All right, so this is the claim. And we can do some examples to kind of show what this claim is saying. So if we take a number that's divisible by 10, let's say 100, all right, we know it's divisible by 10 because it ends in a 0. Then it's saying this is also divisible by 5. Well, is 100 divisible by 5? Well, yeah, sure it is, right? Because, well, it ends in a 0. 100 divided by 5, that's going to be 20. All right, so is divisible by 10 and by 5. And we could do another one, let's say 20, right? 20 is divisible by 10. All right, 10 times 2 is 20. But it's also divisible by 5, since 5 times 4 is 20, right? All right, 20 divided by 10 is 2, 20 divided by 5 is 4, so in both cases, 20 is divisible by 10 and by 5. All right, so these examples both seem to support the claim that if the number is divisible by 10, then it's also divisible by 5. Now, do you think you can come up with an example of a number that's divisible by 10, but not by 5? Well, it might be pretty tricky, and the reason is, and this claim is saying that there shouldn't be such a number, right? Every number that's divisible by 10 should also be divisible by 5. That's what this statement is saying. But how do we go and show it's true? Well, we showed it's true for 100 and we showed it's true for 20. Is that good enough? Well, it's not quite good enough, right? Because just because we've showed it for these numbers, we haven't shown it for every number, right? So we'd have to show it for 10, then 20, then 30, then 40, then 50. But the problem is we have infinite numbers to check, right? We can't show that it's true for every single number just by using examples. So we have to do something a little bit different where we don't refer to any specific example, but rather we refer to the idea of the property of being divisible by 10 and the property of being divisible by 5. And hopefully that'll give us kind of a clue as to how we're going to show that this is true for every number. All right. So this is a little bit abstract, and kind of as you go through math and start like proving claims a little more generally, it'll start to make sense and the pieces will start to fit together and you'll kind of get the flow of things a little better. So let's go through this nice and slowly together and let's see how we can go about showing this. So we're saying that if a number is divisible by 10, so let's start with, suppose we have a number that's divisible by 10. All right, so we have a number that's divisible by 10. It could be 100, it could be 3,000, it could be 20, as long as that number is divisible by 10, right? And now what we'd want to do is show that the number is divisible by 5, right? Because that's the whole goal here. So if it's divisible by 10, what do we know about the number? Well, the divisibility rule by 10 says it has to end in a 0. So if that number is divisible by 10, it must end in a 0. So it must end in a 0. Okay, that's good. But the thing is, now we want to show the number is divisible by 5. But how can we go about doing that? Well, what are the rules for being divisible by 5? The number ends in a 0 or a 5. But the number ends in a 0, right? So that means it's going to be divisible by 5 since it ends in a 0. So since the divisibility rule for 5 says a number is divisible by 5 if it ends in a 0 or a 5, this number must be divisible by 5. All right, so let's just review this one more time. So we're taking a number that we're supposing is divisible by 10. If it's divisible by 10, it has to end in a 0, right? 100, 20, 300, they all end in zeros. But we know that the divisibility rule for 5 says if a number ends in a 0 or 5, it's divisible by 5. And since our number that we started with has to end in a 0, since it's divisible by 10, it has to also be divisible by 5, right? And like, for example, in the case of 100, It ends in a 0 since it's divisible by 10, but because it ends in a 0, it's also divisible by 5. 20, it ends in a 0 since it's divisible by 10, but because it ends in a 0, it's also divisible by 5. So because the divisibility rule for 10 is basically included in the divisibility rule for 5, we basically get guaranteed that, hey, any number divisible by 10 is also divisible by 5. And we show that's true by looking only at the divisibility rules here. All right, so I hope that made sense to you. Let me know if you have any feedback or how well the explanation worked for you in the comments. And let's move on to number 6, which is going to be somewhat similar. So if you're a little bit confused now, hopefully number 6 will clarify it for you. All right, so number 6 says, prove the following claim. If a number is divisible by 9, then it's divisible by 3. All right, so this has a very similar flavor to number 5. So we could do some examples. So let's take a number that's divisible by 9. Let's say like 27. All right, so 27 is divisible by 9. And we can check, right, because we have 2 plus 7, that equals 9, and 9 is a multiple of 9. Great. But is it also divisible by 3? Well, 2 plus 7 was 9, which is a multiple of 3, so it is, yeah, it's divisible by 3. So this number that's divisible by 9 was also divisible by 3. Let's try another one. Let's go with, let's say 99. So if we do 99, well, we can add up the digits. We get 18. That's a multiple of 9, so 99 is divisible by 9. But is 18 a multiple of 3? Well, sure it is, right? 3 times 6 is 18. So this number is also divisible by 3. So in these examples, we get that the number that's divisible by 9 is divisible by 3. But again, we've only shown it for 27 and 99. What about every single number that's divisible by 9? We can't show that all on a single page or in the time that we have in our lives or in the time of the universe, right? There's infinite numbers that are divisible by 9. You just have to keep counting by 9s. So that means we need to use a more general way of approaching this where we just refer to the divisibility rule of 9 and the divisibility rule of 3 and hope that we can glean something from that. So let's start with saying that suppose we have a number that's divisible by 9. All right, so we don't know anything about this number. It could be any number. All that we know is it's divisible by 9. And now we want to show it's divisible by 3. If we show it's divisible by 3, we'll know that any number that's divisible by 9 is also divisible by 3. The number is divisible by 9. So what does that mean with our divisibility rule for 9? Well, the divisibility rule for 9 says that the sum of its digits is now a multiple of 9. So we can write that down. So the sum of its digits must be a multiple of 9, right? All right, awesome. And what does it mean to be divisible by 3? Well, it means that the sum of the number's digits is a multiple of 3, not 9, right? But the thing is, 9 is a multiple of 3, right? We know that 3 times 3 equals 9. That means if a number is a multiple of 9, it's also got to be a multiple of 3. 99, that equals 9 times 11, right? So that means that 99 is a multiple of 9. But if we look at 9, that's the same thing as 3 times 3, right? Because 9 is a multiple of 3. But then we can rewrite this 3 times 11 here as 33. And we see, hey, 99 is actually a multiple of 3, right? Because this is the same thing as 3 times something. So since 9 can be written as 3 times something, the fact that the number is a multiple of 9 means it also has to be a multiple of 3. All right? So 9 is a multiple of 3. So the sum of the digits must also be a multiple of 3. But if the sum of the digits are a multiple of 3, that's exactly the divisibility rule for 3, right? So the number must be divisible by 3. The number we started with must be divisible by 3. All right, so just to recap, we took a number that's divisible by 9, and the fact that it's divisible by 9, the rule tells us that the sum of its digits had to be a multiple of 9. But we know that 9 is a multiple of 3, right? 9 is 3 times 3. But that means that the sum of the digits must also be a multiple of 3, right? They're a multiple of 9, which is a multiple of 3, so the sum of the digits is also a multiple of 3. So that means the number that we started with must be divisible by 3 because the sum of the digits being a multiple of 3 is exactly the divisibility rule for 3. So without using any specific examples, we've shown that any number that's divisible by 9 also has to be divisible by 3. So that means if you have a number that's divisible by 9, you can also know for a fact it's going to be divisible by 3. All right, so I hope those made sense to you. If you have any questions, please let me know in the comments. And I hope you enjoyed the lesson. But that's all for me today. Have a good one, stay groovy, and I'll see you in the next video.